So we need to cover a couple sections here in Chapter 5 before we can work on the lab. So Chapter 5, we're going to start talking more about compounds. Okay, so far we've been mostly focused on individual atoms. What's in the atom? Where are the electrons? Where are the protons? Where are the electrons' levels? How stable are the electrons? Is it easy for the atom to lose electrons? Is it more likely to gain electrons? When it adjusts the number of electrons, it will create a charge. How's that going to affect the atom? Well, what we've talked about a little bit is when an atom has a charge, if I have an ion, that results from the atom having a charge, and usually that occurs because of the noble gas configuration. Right, so if I have something like chlorine in nature, it won't be found as chlorine, it will be found as chloride with a negative charge. And if I have something with a positive charge, like magnesium, the way magnesium is found in nature, in like mineral water, magnesium is one of the metals or minerals that's in there, but it's always found with a 2+ charge because it needs to lose 2 electrons to have the same number as a noble gas. You won't find it at neutral magnesium in nature. So since so many elements are capable of forming charges naturally, in nature, when they come together, since they have opposite charges, they will attract. And so one type of compound is an ionic compound that involves oppositely charged particles attracting. So if the magnesium and the chlorine come together, due to the fact that they have opposite charges and due to the fact that they actually have charges because they need to have the same number of electrons as the noble gas to really be stable in nature, I will also bring them together in a ratio that creates an overall balanced charge. Right? So if I only have 1 magnesium and 1 chlorine, it's not balanced. If I had this in nature, what would happen? Well, since it has twice as much positive than it does negative, well, that extra positive would just start attracting something else naturally. So it's going to attract another ion to it until it creates a stable formula. So it probably would attract 2 chlorine. And so I would write that compound combination of 2 elements as magnesium chloride, or MgCl2. I've got 2 chlorides there to keep the overall charge balanced. So that's one type of compound. Any compound that involves any ion, any element with a negative charge and any element with a positive charge coming together is an ionic compound, also known as a salt. So when you hear the term salt, that's not just table salt. There are lots of different examples of salts. Any compound that involves an ionic bond or that involves a positive and a negative of some quantity on atoms that get attracted, that is a salt. Okay? So salts are one type of compound. Compounds fall into 2 categories. Salts, which are ionic, and molecules, which are covalent, which we'll talk about a little later. So don't worry about covalent for now. The salts are more simple. It's really not complicated. You have these atoms that are more stable if they have the same number of electrons as a noble gas. And when they have that number of electrons, it creates an imbalance in their charge on the individual atom. So because those individual atoms have an imbalance in charge, when they have opposite charges, they come and they attract, and that forms a compound. It's a pretty strong attraction. Right, so if I take this example of magnesium chloride, and I take this neutral unit, and I put it next to another one, and like pack these together into a organized 3-dimensional arrangement, what's holding this solid thing together, all these units together, is the fact that the opposite charges attract. So the chloride, the negative, is going to be attracting to the magnesium in this unit, it's going to be attracting the magnesium in the next unit. all of the charged particles are going to arrange in an organized way so that the positives are surrounded by negatives and the negatives are surrounded by positives. That's going to hold that together. It's a pretty strong attraction. If you want to take that solid and melt it, it takes a lot of energy. If you recall back to the first lab, some of the groups had like an NaCl or an Na2SO4 or an Na2CO3. Those were salts. If you had one of those where you put your sample in the melt temp and it never melted, it didn't melt because these are charges that are attracting. These are strong attractions. It wasn't a magnesium, it was a sodium, but it was a sodium and a chloride, a positive and negative, or a sodium and a sulfate, a positive and a negative, or a sodium and a carbonate, positive and negative. In either case, it was a pretty strong attraction. In order to take that organized structure of charged particles attracting through full charges and melt it, you'd have to put enough energy in so they're vibrating enough so that they break their positive-negative attractions and able to flow away from one another. It takes a lot of energy to do that. So ionic compounds usually have high melting points, very high melting points, because of the charge attraction that's holding them together.